Modern cruise ships are truly impressive machines when it comes to their size, design, and the technology on board. Mainly, it's due to the number of passengers they carry. With the largest of them, the newly launched Star of the Seas belonging to the Royal Caribbean Group, being able to carry a maximum of 7,600 people at once. Spanning 20 decks, the trip usually lasts 7 days. These cruises, which are actually floating cities of the highest luxury and glamour, offer countless attractions to make the trip a once-in-a-lifetime experience for anyone. They have a multinational crew made up of around 2,350 people from various specialties, accommodated in an area that covers 4 decks of the ship. The Star of the Seas, the largest passenger cruise ship in the world, weighs, or rather displaces, an incredible 250,800 tons, with 364 meters in length, 66 meters in width, and 20 luxurious decks. What makes it a true Star of the Seas, a star that is fueled by something? Around 180 tons of food for all its guests. Over the course of the 7-day trip, 7 days that go by really fast since the ship has a water park. Category 6, the world's largest at sea. A surf simulator, the Flow Rider, and the largest absolute zero ice arena at sea. In addition to 7 pools mini golf, a climbing wall, several show stages, and many other attractions. There are so many options and so much happening at the same time that it can be extremely hard to decide where to go. And even when you're at the best possible attraction at the moment, you'll always get that feeling that somewhere else things might be even more interesting. It's a floating metallic city slowly crossing the seas. It's even hard to believe that something so big and so heavy can simply float on water without sinking. But that's possible because of Archimedes' principle, which in simple terms explains that the buoyant force, which is the force that water exerts upward, is equal to or greater than the weight of a ship. This happens because even though it's large, the ship has big internal spaces filled with air, not with mass. And that makes it less dense, less heavy than the water it displaces. When it's stationary or moving, that's why it floats. Now, if a lot of water starts to get inside, like with the Costa Concordia or the Titanic, then it gets heavy and will sink. But the biggest problem, even for the large cruise ships, is with the fuel. Due to their enormous mass, moving these cruise ships across the seas at typically 22 knots, which is about 41 kilometers per hour, requires really a lot of power. This power is provided by 3 azimuth thrusters, or azipods, which is a propulsion system for ships that consists of a motor mounted in a propulsion unit called a POD, which is rotatable and can turn 360 degrees, improving maneuverability and fuel efficiency. It replaces traditional propellers and rudders and is used in various types of vessels, such as cruise ships, oil tankers, cargo ships, and icebreakers. In this case, ships with azipods are diesel-electric vessels. In other words, they have diesel engines, usually 6 of them, with 3 14-cylinder engines and 3 12-cylinder engines that run on liquefied natural gas, or liquefied natural gas. It's the same gas used for home cooking. However, it is cooled to minus 162 degrees Celsius to become liquid and reduce its volume by about 600 times. This allows ships to carry larger amounts of fuel in the same space and also makes transportation easier. An interesting fact about liquefied natural gas is that it has no smell, no color, no taste. It is not corrosive, and in its liquid state, it is not flammable. That typical smell of cooking gas is intentionally added for safety reasons. Otherwise, no one would know about the gas leak in the house. The energy produced by the ship's 6 engines powers the vessel's 3 20-megawatt electric motors, which are the ice pods and make the ship move. 20 megawatts of energy is enough to power about 10,000 average homes at once. The Icon of the Seas, and probably its younger sister, the Star of the Seas, have two gigantic fuel tanks that, when empty, weigh 307 tons and measure 27.5 meters in length. They can hold anything above 3,400 tons of manufactured natural gas. That's because these ships consume an incredible and absurd 250 tons of fuel per day. Just think about that. They're true liquefied natural gas guzzlers. The cost of all that fuel also fluctuates depending on the market, the contract, the region, and the port the ship uses. Fuel prices at this scale are measured per metric ton, with average prices ranging from $530 to $865 per metric ton. This means that fueling a ship costs anything above $2,244,000 just for fuel on a trip that will last only 7 days and cover a distance of about 3,150 kilometers. $2,244,000 just for fuel is a considerable amount, but it might seem little given the number of people the ship can carry, assuming the minimum ticket price is $1,000. But fuel accounts for 25% to 35% of the total operating costs of a cruise of this size. And that's not even counting the other costs, like crew salaries, maintenance, supplies, insurance, ports, taxes, various services like internet and satellite television marketing, among others. Then the question arises, why aren't cruise ships powered by nuclear energy to make them cheaper, more economical, and more efficient? The largest nuclear submarines use just over 45 kilograms of nuclear fuel to sail continuously for 25 to 30 years without the need for refueling. 30 years of pure autonomy. This fuel is uranium-235 enriched to 93 or even 97%, which is considered weapons grade. The reactor uses this fuel to generate heat and boil large amounts of water to produce steam, which will drive turbines, providing unlimited energy for propulsion and various electrical systems on board. While the submarine stays submerged for up to 6 months, surfacing only to change crew and resupply provisions. According to some unofficial estimates, a kilogram of uranium enriched to 90% costs around $45,000, which translates to just over $2 million for 45 kilograms, which is extremely viable, beneficial, and economical for a cruise, since it provides autonomy for more than 30 years without the need for refueling, besides not emitting polluting gases. With such energy power, such autonomy, and low cost, the fuel is nuclear. It would be the perfect solution to be used in cruise ships. However, it is not used, and there are a number of reasons for this non-adoption. The main issue is the high cost of designing a nuclear cruise ship. A cruise ship fully powered by nuclear energy would be great and would save the company millions of dollars annually. However, it requires a design completely from scratch, which would be extremely expensive, time-consuming, and would require other types of qualified professionals, mostly from the military field. The Icon of the Seas, for example, cost approximately $2 billion to build. It depended on the daily work of over 2,600 employees from different fields, with the total number undisclosed, and it took about 900 days to be completed. That's assuming a fully established supply chain already exists for all kinds of items, such as parts, equipment, and machinery. Everything already properly tested and certified to be on board a ship full of people. The entire process, from initial concepts to the ship's completion, took over 7 years. Now, regarding a nuclear-powered ship, a completely new supply chain for parts and machinery will need to be built almost from scratch for this purpose, and a complete change to the standard design of cruise ships to replace the diesel engines, the huge fuel tanks, generator shafts, among other things, to house a highly safe nuclear reactor specially built for this purpose, since the energy requirements vary from vessel to vessel. In addition to a huge containment structure, which is the shielding, around the reactor for protection against radiation, shipwrecks, and accidents in general, such as explosions. Steam generators, a reactor cooling system, new pipelines, backup systems, among others. They would need to be designed from scratch for this purpose. Designing all this would take years, require extensive testing and experiments, and be extremely costly, especially if it was just to design a few units of nuclear ships. The second factor is related to port restrictions and regulations. The main beauty of a cruise ship is the freedom of navigation and the ability to visit the desired destinations. Many countries and coastal cities have laws that explicitly prohibit the entry of civilian nuclear ships into their territorial waters or ports, due to public safety and environmental concerns. This is the case with nuclear-powered icebreaker ships, which cannot dock in just any country, city, or port. What if, while breaking through thicker ice, the hull and nuclear reactor cracked, causing an unnoticed radioactive leak? I think that's what the authorities in those countries believe. Other countries, even if they don't completely ban it, require a complex and lengthy government approval for each visit. The International Convention for the Safety of Life at Sea has a specific chapter. For nuclear ships, the vessel is required to have detailed nuclear safety documentation. This documentation must be provided to the contracting governments of countries the ship plans to visit with adequate advance notice. In addition to standard safety inspections, nuclear ships are subject to special inspections before and during their stay in ports to verify the validity of the safety certificate and ensure that the reactor is operating within regulations. Nuclear propulsion would, in short, require international cooperation and permission. That just doesn't exist in civilian tourism, restricting the ship to such limited routes and ports that the business would be unfeasible. Another reason, perhaps one of the most impactful, is related to public perception. The main barrier isn't the technology, which is safe, but how is it perceived by the average passenger? In an industry offering vacations, relaxation, and unique experiences, any hint of risk can severely hurt demand. The term nuclear carries a very strong negative public connotation associated with accidents like Chernobyl or Fukushima and the release of radiation, which can not only damage the DNA of everyone on board, but also of thousands of other people, including even future generations. It can also render hundreds of hectares of land unusable for decades and contaminate seawater. This highly unlikely but not impossible scenario has nothing to do with a safe vacation. For companies like Royal Caribbean or Carnival, associating their brand with something as controversial as nuclear energy could lead to public backlash, falling stock prices, boycotts, and serious damage to their reputation. In addition, there's the issue of specialized crew. Unlike a military ship, the crew of a cruise ship, such as waiters, housekeepers, technicians, engineers, helmsmen, entertainers, among others, do not have nuclear safety training. Maintaining a dual team mainly of military personnel and nuclear energy veterans would be very costly and bureaucratic, considering that it would be necessary to have other similar teams on all the nuclear vessels the company owns. But things would get even worse if they chose to provide nuclear safety training to the entire crew on board, which, as we've seen before, can consist of more than 2,350 people on each ship. The cost of all this training would be highly prohibitive for any company in the field. This training needs to be much more intensive for engineers, mechanical technicians, and ship commanders who need to become true experts in nuclear energy to be qualified to operate a nuclear vessel. Not to mention that salaries will have to be increased. These are just some of the reasons why there are no nuclear-powered cruise ships, but there are several others. Like what to do with the already used nuclear fuel, the high cost of decommissioning the vessel. Since while a conventional cruise ship is sold for scrap or dismantled in a regular shipyard at a relatively low cost, a nuclear ship requires a dismantling process with specialized personnel. It's extremely expensive. In addition to losing the main benefit of a nuclear vessel, which is being able to sail continuously for long periods. On the other hand, a cruise ship tends to dock at a port every 7 days to exchange passengers and restock supplies. This compromises its true nuclear purpose.